Good morning. Oh, shoot, it's afternoon. Good afternoon. Welcome to day number 2 of the University Research Symposium. Before we get started with today's program, I just want to go over a couple logistics. For those that haven't been in Hunt Library before, the bathrooms are located directly across this entrance here in a yellow alcove. So please use the restrooms and go out for a break if you need that. We will continue to have break service, coffee, tea, and there will be snacks being brought out partway through today's program on the tables in the far side of the room. And then the last thing I wanted to mention before I turn things over is many of the resources and items that are mentioned during today's symposium, as well as yesterday's program, as well as some of the recordings of our agenda items are going to be posted on the University Research Symposium webpage following today's event. And you'll find that easily by going to go.ncsu.edu/research-symposium. And anybody who registered will be receiving an email following once all the online resources are posted to the webpage. So I just wanted to make sure we're all aware of those. And then to start our program, I want to invite Dr. Heather Pattisall to join me on the stage to give us a brief welcome to day number 2. Dr. Pattisall is the chair of the URS Planning Committee this year. So,
Thank you, Laura. Good afternoon, everyone. Very excited that you've been able to join us for day 2 of the University Research Symposium. Yesterday, we had some great conversations and learned a lot about some amazing research that's happening at NC State with some of our partners. And got into a little bit of discussion about the ethics of AI in the morning and defined some key terms. And so today on day 2, we're going to delve a little deeper into the research happening on campus with some lightning talks and people giving examples of what they're working on, and try to come together to find the path forward for NC State in data science and AI. And so to begin today's program, I want to turn it over to Dr. Ray Levy, the Executive Director of the Data Science Academy here at NC State. Ray will be moderating a panel on the AI Bill of Rights. And this panel will provide a general awareness of the AI Bill of Rights, which is very easy to Google if you want to pull it up while we're having a conversation about it, released by the Office of Science and Technology Policy from the White House. And we'll use this time to focus on the 5 topics identified in that Bill of Rights, which are safe and effective systems, algorithmic discrimination protections, data privacy, notice and explanation, and then human alternatives, consideration, and fallback. And so with that, I turn it over to Dr. Ray Levy.
Thanks, Heather, and thanks, Laura, for all of your help organizing all of us to do everything this last 2 days. So I'm very happy to be here with you today with this excellent panel. And I want to point your attention to a handout on the table that has a QR code. So everybody look. You should have a handout like this. It has the 5 topics that we just mentioned. And it also has a QR code that'll take you to the blueprint for the AI Bill of Rights if you want to check that out afterwards. And we already heard about what the 5 topics are. So we're going to have our panelists introduce themselves. But first, I also wanted to mention that last night, Dr. Ruha Benjamin from Princeton gave a talk. She gave the Gerald H. Elkin Distinguished Lecture in Science and Society for the Park Scholars Program to a packed ballroom in Talley. And that was recorded and will be available on the Park Scholars website. And one of the things that she especially pointed to was the blueprint for the AI Bill of Rights that we're going to talk about today. So if you do decide to look at this with your students or want to learn more about it yourself, I think that's also a fabulous talk that would be very accessible to students at any level to get them to start thinking about some of the issues around data and people. So let's get started. We're going to have our panelists introduce themselves.
Okay. Hi, I'm happy to be here today. I'm Helen Armstrong. I am a professor in the College of Design, and I'm also the director of our Master of Graphic and Experience Design program. And my research looks at interface design, human-machine teaming, and accessible design. So you could also think about that as leveraging AI capabilities to respond to complex problems through design.
My name is Veljko Dubljević. I'm a university faculty scholar and associate professor of Science, Technology, Society, and Philosophy at NC State. I also lead the Neurocomputational Ethics Research Group, and I'm one of the founders of the AI in Society group at NC State.
Good afternoon. My name is Julie Ivey. I'm a professor in the Edward P. Fitz Department of Industrial and Systems Engineering, and I also direct our Masters of Engineering Management program. My research is in decision-making under uncertainty, and in particular, I look at ways that we use data to inform or improve decision-making in problems in healthcare, humanitarian logistics, and education. And so one of my interests in particular with respect to AI is thinking about unintended consequences of models that we build and how we're responsible for the underlying decisions that we make using those models.
My name's Kevin Lee. I am the Intel Social Equity and Racial Justice Professor of Law at North Carolina Central University Law School. My research focuses on jurisprudence and racial equity.
Thank you very much. So in this symposium, it's been really important to us to give you all time to talk to each other, not just to have us always talking to you. So what we'd like to do is if you're sitting at a table by yourself, you may want to scooch over to another table. The first thing we want to do is have you just pair with someone and think about how does ethics come up in your work or come up in your research. And just take a minute or two, share that with someone, then switch. We're going to have one more opportunity at the end for you to think forward about in your own work how you might want to take some of the ideas that we're talking about here and further embed them in the work that you do. So just take a couple of minutes, make sure you both get a chance to talk, and share how does ethics come up in your work. Okay, if the other person didn't have time to talk, switch. You just got started, that's great. Okay, so wrap those conversations up. Is there anybody who wants to share one idea about how ethics comes up in their work? If you share, I can repeat what you say because we don't have a mic coming around. Just can you raise your hand? Does anyone have a way that ethics comes up in their work? I'll get 3 ideas and then we'll move on. Yes. Personnel issues, it comes up. Yeah. Providing access of research results broadly to everybody. One more. How does ethics come up in your work? Dealing with equity issues on a North Carolina State campus. Thanks for those thoughts, and I hope that everybody has something in their mind about a way to relate the issues that are coming up here that have clearly been brought up on a national level, bringing that to a local level and thinking about how our work impacts our local community, and then how, as our work spreads out, we go back to impacting globally. Oops, sorry. All right, so first we'll get into the topic of the blueprint. We'll start with Kevin. Kevin, will you please start us out with a little introduction? What is this blueprint for an AI Bill of Rights?
Yes, okay, thank you. I wanted to start out just by giving some background and then looking at the nature of the document itself from a legal standpoint, because that's my field. I would say if you go back just 20 years, the idea of a document like this would be hard to imagine, actually. In 2016, the first document of this sort came from the Obama administration in a report titled Preparing for the Future of Artificial Intelligence. And at that time, the document, or the approach that the administration was taking, was mainly just supportive, and it was a document that was, I would say, largely hortatory, setting goals and encouraging development of artificial intelligence, not so much stressing the ethical implications. And then in 2019, the Trump administration put out an executive order. Executive orders do have the force of law, but the Trump administration's executive order was titled On Maintaining American Leadership in Artificial Intelligence, and it was mainly geared towards encouraging public-private cooperation in developing. And again, the ethics issues weren't really on the table. I had to do a quick check to think about what changed, okay? And a number of ethics issues came up with considerable force, I think, between that statement and the beginning of the Biden administration. There were privacy concerns. For example, famously, in 2018, it was revealed that Cambridge Analytica had obtained personal data from millions of Facebook users without their consent and used it to influence the 2016 election. There was a scandal involving Google in discrimination in hiring processes that came out around 2020. And then there was the facial recognition scandals that came out during the Black Lives Matter protests all across the country, with specific instances of police departments using facial recognition technology to identify people who were in the act of committing a crime. And then I think there was also, in 2019, there was a statement by it's called the Digital Cooperation, a report of the Secretary General of the UN, that began to look at the power distribution between the sort of haves and have-nots, the developed countries versus the developing countries, and realizing that the developed countries are often gaining access to and exploiting the data from developing countries. And this sort of concept of data colonialism came to the foreground in that document. So then along comes, in 2021, UNESCO put out a statement of guidelines and principles. All the UNESCO member countries signed on to it, including the United States, and it had some basic ideas about human-centered design, ethical considerations, inclusiveness, data protection, and so on. And so then 2021, the Biden administration begins to plan for, or it's one eventually releases its blueprint for an AI Bill of Rights. This, again, is not a legally binding document. It's a statement of aspiration more than a legally binding document, but it's a statement of policy as well. It does put ethical considerations on the agenda in a way that hasn't been done previously. And I think that's one of the important aspects of it. I can go on. I think it's pretty good place to end, though.
This blueprint, is or isn't a legal document at this point, the one that we're going to talk about today.
Right. It's a statement by an office in the executive branch. It's certainly influential as a policy statement for the the heads of the administrative agencies, but it doesn't have any legally binding effect.
Thank you. All right, Velko, we're going to start with you on safe and effective systems. How do we start thinking about safe and effective systems?
So first things to know is that AI systems can come in different shapes and forms. So some of them are embodied, and those that are embodied may present more safety issues. So think of autonomous vehicles or robots. Other agents are virtual, but that doesn't mean that they don't pose any safety issues. For instance, in the early stages of Siri, people who were depressed could say something like, "Oh, I'm so depressed, I want to kill myself." And Siri would very helpfully say, "The next bridge is 2.5 miles away, you can jump off there." So what I want to say, and I want to keep this brief, is that engineers and developers need to be very careful that AI systems are helping humans in good endeavors, and that the AI systems are not basically facilitating any harm. I'll end there.
Thank you. Julie, we're going to pick up with you. More than 10 years ago, we didn't hear so much about algorithmic discrimination. In terms of algorithmic discrimination protections, what should we be aware of?
I think that when we think about AI, we can't think about AI without thinking about the data that is used to feed it, right? And so if we think about the data that's used to feed it, often we use terms, like we talk about data as though it's just numbers in a page, but data represents people and actual actions and things. And so we can't use data without thinking about its context from which it was derived. If we think about data from the context from which it's derived, we also have to be aware that embedded within that data are endogenous decisions. I do work in healthcare, so when I look at electronic health record data, embedded in that data is the decision making that was performed by clinicians. They decided when to take tests, when not to take tests. They decided what to do next in terms of treatment. I can't assume that those actions, just because they're present, were the best actions or the most equitable actions or fair actions. And so when I build models based on that data that has those actions embedded, by definition, I'm learning potentially from a biased data set and biased actions. And so then there comes this thought that my model, therefore I have to think about what are the consequences of what's embedded in that model. How are decisions being influenced by what's embedded in that model? So if we think about something like ChatGPT, right? And we talk a lot in academia about things like cheating with ChatGPT, but I mean, that's really insignificant. What we really need to be thinking about is how decisions are being made. So where is it embedded, right? It's embedded in Salesforce. Microsoft has invested heavily, and so therefore the actions that we see and decisions that are being made are embedded in those data systems. And so there are several examples of bias that is manifest, both in terms of how resumes are reviewed and what keywords are identified, what names are identified in terms of being successful candidates and how people are weeded out. There are things in health where some who receive less health resources are therefore learned by the system to need less health resources, all right? And so if we ignore the data in the systems that we are learning from, then we propagate and in fact make discriminatory practices worse than they might otherwise be because they're actually fairly mass and deeply embedded into systems. And so I think it's upon us to not say, well, the model made me do it. We have to build models and understand what are we putting in there? What are the consequences of the models? Where might it be making mistakes? Can we identify explicitly where there are biases that are being produced by the models that we build? And so I'll leave it at that.
Yeah, just to follow up, as we're starting to think about our own research, can you give us some tips about how we might get started thinking about these issues in our own labs or our own projects?
Well, I mean, I think the very first thing is we need to interrogate both the data and our models that we develop, right? And so, as I said, it's not okay to say that the model made me do it. What does that mean? That means that then we have to dig deeper. We have to understand context around data that we use. We have to understand where models themselves are potentially biased. All models are wrong, right? But some are better than others. So how can we begin to do that? Some of the things that we see, which scares me a little bit, at least in my field, we see sometimes that people will remove race or gender from the model because then the model will be unbiased. Well, that doesn't make the model unbiased. What it does is mask potential biases that might be present. And so therefore, we really have a bigger responsibility in terms of developers to really look deeper at our models, to really try to break them, really, as best we can, without trying to take a hands-off approach. And that's what I would suggest.
Thank you so much. All right, Kevin, we're going to pick up with you with data privacy. Should we be thinking about certain things with respect to data privacy?
Yeah, data privacy. You know, I've been thinking about this over the last couple of weeks, and one of the things I wanted to share with you is just a thought about privacy in general as a legal right. You know, privacy is very hard to define, and as a legal right, its evolution has been uneven. There was, you know, in 1790, the common law of privacy really referred to revealing something about a person that would cause them material harm. And it was only actionable if you could prove the material harm. So ideas like personal integrity and psychological well-being weren't part of the common law. And I think that's still, until, you know, it begins around 1900, and it actually begins with the development of the tabloid press and brownie cameras, right? And you know, people are getting photographs taken of them and embarrassing. And so that's actually when privacy begins. So it's a new concept in itself, and it's very uneven the way it's being understood. I can tell you the blueprint for the Bill of Rights looks to several things. One is the protection of personal data is given a special place in this. With the idea that individuals' data needs to be protected from misuse, unauthorized access, and other forms of exploitation. Part of that is individuals should have personal control over what data gets collected and how it's used. And in order to achieve that, there has to be transparency and accountability. Transparency here means that individuals are given an opportunity to know what data is being collected, by whom, and what use it's being put to, right? And have some control over it. And then accountability in this case means that the organizations have to be held accountable for misuse of it. Fairness and non-discrimination is another principle that's very important in that. And then I think also important to the document, there's a real strong emphasis on continued international cooperation with the realization that these rights that are developing can't really be achieved without international cooperation. Data doesn't respect national borders. The other thing I would say about that is, just really quickly, that the blueprint then that's put forward is definitely a step forward. It's very different from other regimes for protecting privacy rights that are developing around the world. And I think one of the distinctions compared to, for example, the EU approach, in the EU, data privacy is considered to be a human right. And therefore there is much less commercialization, commercial exploitation permitted, right, under the EU approach. The US approach is been more flexible in allowing more commercial exploitation and not declaring it to be a human right. Now, this document in itself couldn't declare something to be a human right anyway, because as I said, it doesn't have the effect of law, but it also is holding back from that step, right, compared to other regimes around the country. So, in the US, I think you have to look at, with essentially 51 jurisdictions vying for control, there's a lot of difference. Just really quickly, facial recognition. Some of the facial recognition software has been banned internationally. It's been banned in specific states. And yet, I can think there's one called Clearview AI. It can be used in North Carolina, and the decision is made by each police precinct. So, there's no coordinated even control mechanism in the state. Oops, sorry. Let me.
Okay, thank you. Helen, we're going to pick up with you on notice and explanation. So what is meant by notice and explanation, and how does this come into your work? And then how should we think about it in our research?
Okay. Notice and explanation. Well, a lot of these AI systems, as we've been discussing, I think alluded to over the course of this symposium, are fairly invisible to the typical user, yet they have these widespread impacts. So and as I think we've talked about as well, those impacts can be quite apparent. You didn't get a job, you didn't get a loan, you didn't get parole because of the decisions of these systems. They can also be more subtle. So what information you're seeing or not seeing, or how it's being portrayed to you, or what kinds of actions you can take. So when we think about notice and explanations, we're really thinking about making apparent to people when these systems are in use and how they are impacting humans. And we can think about that in a lot of different ways. We can think about it, some specifics might be encouraging or enabling people to opt in rather than opt out of systems when possible, understanding what data is being collected and in whose interest, empowering people to drill into some of these data sources to verify them, or even drill into insights, AI insights, to understand how credible they are. Across the, sorry, I'm losing my voice a little bit. Across the board, people tend to overtrust these AI systems right up until the moment in which they disagree with the decision. And in that moment of disagreement, that's when trust begins to erode. And that erosion of trust is a big problem, because we need trust in order to be able to team with these systems. So going back to notices and explanations for a minute, thinking about ways in which we can provide both information and agency to people through notice and explanation is really key when we're building these kinds of systems, in order to reinstill trust in the experience with the systems. We can also think about things like embedding transparency in these systems so that the systems themselves are more trustworthy to begin with, and we can hold these systems accountable. I want to go back to something else that's in the Bill of Rights that I think is really interesting around notices and explanation, and that is thinking about three things. Thinking about making these systems, thinking about portraying these systems in ways that are clear, timely, and accessible. And these are three things that as researchers I think we can think about quite a bit. Clear as in using plain language or logical, intuitive visualization. Timely as in moment of use. So thinking about notice and explanation in the moment of use so that context is very clear to the user of the system. And then finally, accessibility, thinking about making these systems accessible to a wide range of both physical and cognitive abilities. So I think those are three things that are mentioned in the Bill of Rights, maybe in a more secondary way, but that I think is really important for the way that we build these systems and conduct research around these systems.
So when the notice is 50 pages long, and you're trying to say yes or no in the moment for something you know you need to do right then, in those three issues, is it hitting more than one? So I heard it in the accessibility, right? That it's not very, you don't have the time or even maybe the knowledge to read the legal document and understand what you're agreeing to. Does it also hit the clarity or the middle one that you mentioned?
Yeah, I would say it touches on both, right? Thinking about designing these moments of intervention in which you're providing explanation in a way that people can actually comprehend in the moment. That gets to your point about length, right? The language that's used, the depth of jargon. This goes back to plain language. You can also provide notice and explanation in a way that unfolds over time, so you're responding to small, simple explanations in the moment that they're applicable, rather than reading that 300-page explanation that's obviously not written in the best interest of the user, right? It's instead written for someone else's interest entirely. So providing experiences for people that allow them to actually engage in these explanations in ways in which they have user agency to say yes or say no, or to, when they disagree with these systems, have recourse to take actions and have those actions available to them.
One of the things it makes me think about is the IRB documents in some of our research and how long some of them are, right? And how can we maybe work with IRB to make some of those, follow some of those principles of clarity, or understandability, or concision. So thank you so much. All right, and we have one more topic, and then we're going to have conversation and maybe even some time for Q&A. So human alternatives, consideration, and fallback. We're going to hear from Velko and then Julie.
So when we're talking about human alternative consideration and fallback, we need to know that AI systems are not created in a vacuum. They are implemented in society. So let me give you a couple of examples. So we have a shortage of truckers and we have a shortage of nurses. And we say, okay, AI and computer science people help out with this. And then we create automated vehicles, trucks, and we create nurse box. Awesome, right? Well, it's awesome because we can actually have an alternative. A truck driver doesn't need to sit in a truck driving from San Francisco to New York, but because that's cruel and horrible, right? You don't want to be on that much of a long trip. And that's where the AI does good, but it also risks displacing the driving profession. So we need to be thinking of how to implement AI systems so that we have some meaningful engagement with these professionals so they can actually adapt to the inclusion of AI in society. The other thing to understand is that AI systems will make mistakes, and that there is a crucial local expertise of so-called local experts. So those truck drivers know what happens if there's like GPS does not show that there's road work and downtown Albuquerque or whatever, right? So they know how to deal with that, the machine does not. So we need to engage those experts into dealing with problems that will arise. The issue that we also need to understand is that people will have to team and work with AI systems. And that's not going to happen if it is not clear to people that have to work with those systems that those systems are working for them and not for someone else. To give you the example of nurse bots, unless and until that time that other nurses, doctors, healthcare professionals, as well as patients are comfortable with using nurse bots, it's not going to work. It's not going to fly in the system. So we really need to consider how humans and AI systems interact, how humans and AI system can work together, and how to make sure that humans are actually not being displaced by AI systems, but are actually helped, and that this work in collaboration is facilitated. That's all I'll say.
Yeah, you're reminding me of times, I don't know if you've had this experience of being at the doctor and you have some sort of device that's measuring something and the person that's doing the measurement doesn't like what the machine says, right? And in some cases they'll do it again. In some cases they won't. They'll just be like, oh no, that number's wrong. And there have been some cases where that has been a problematic for people that I know where, disregarding an answer of a number that doesn't seem possible when it was actually real is very dangerous for the human. At the same time, we do need to be checking, right, and double checking the answers that we're getting if for some reason they don't seem right to us. And so how do we balance that mistrust and trust that are actually both necessary in order to keep people safe in a healthcare situation or other situation, I think is really difficult. And again, our healthcare professionals, we just really rely on them, right, for their expertise in these areas. So thanks for bringing that up. Julie.
I mean, I think that brings up the point that we're really not talking about human alternatives as much as human complements, right? That it's the human and the machine working together to improve outcomes. And so we have to, like when I previously brought up the idea of like interrogating models, interrogating data, that means that really we have to understand context. We have to work with subject matter experts to make sure that we understand when, say, for example, that doctor's reading is indicating a significant problem or if there is an error that's present. I'll give an example that when we first started working with our electronic health record data, we were doing these analyses and we're like, oh, this is great. We're finding these neat, novel concepts about these patients and, this realization of their condition. I bet no one ever thought about that. Oops, sorry. Then we met with the clinicians and they were like, oh, those are typos. Yeah, that happens all the time in the system. And we're thinking that we're discovering something incredibly novel, right? And so in absence of us having that partnership where we worked with the experts together to really understand what we were seeing in the data to then be able to build meaningful models, we would make grave errors. And so I think as we think about this human complement, we can't go back, right? We're at a point where AI is not going away, right? But we do want to think about how do we develop systems where we can have this collaborative relationship with AI as we think about delivering good solutions, and that this human is in the loop as we go through our processes.
Thank you so much. All right, so as promised, we are going to ask you once again to think about these 5 areas and your own work. And it would be really great if each of you could pick at least one of these 5 areas that going forward from today, you'd like to pay a bit more attention to in your own work. Okay, so think about that for a minute. And then again, I'd like you to start the conversation with your neighbors. Where might you focus in your own work on one of these 5 areas? All right, let's close those conversations. This is really the most important part of this session, because we can talk about these things, but if you don't take the principles into action, why come here, right? Why talk about things? It really needs to be about what we as an institution are going to commit to doing forward and how we're going to support ourselves in those things, because we're not all experts in all of these areas, but now you know some experts up here. So as you were thinking about your own work or even about these topics in general, are there any questions you'd like to ask our panelists? Mike's going to come to you.
So the question, I got to get far enough away. The question is, I understand the Bill of Rights you have up there, but then I step back and I say, how does it affect the timeliness and effectiveness of your research? Because you may cull out things because you have to follow these rules. So it makes the research even more difficult to do. And I'll take another example of that. If I have another group in, let's say, a non-democratic country, they'll get more data and that because they're not following it, and they'll process along, not necessarily for good use. So what's the answer?
So how do you balance, just to rephrase and tell me if I get this wrong, how do you balance efficiency, right, and timeliness with what almost definitely seems like might slow you down in the process of trying, even if not following rules, but trying to follow practices that would lead to better outcomes? So who wants to take that one?
I'll give it a shot. One of the things I can say is clearly, you know, there is no international law regarding this, or very little, that's relevant. You can see the international organizations moving towards putting out statements precisely for that reason. We desperately need to have some international standards for this. One thing that's absolutely clear is the work that's being done here and in other institutions like this around the world have tremendous geopolitical significance. And, you know, it really comes down to the question, though, of what values are going to be expressed in the work that gets done. You know, will we be protecting human rights? Will we be trying to create a civilization where human values are explored and promoted, right? And I think that at the end of the day is something where everyone bears some responsibility.
If I may add here, so we had similar issues in different kinds of technologies. So for instance, cloning, right? There is no international law banning cloning, but there is this understanding from common human morality that this is utterly immoral to clone human beings. Therefore, even in autocratic countries, they're loath to do that. I think that this set of principles and the conversations around ethics of AI are serving that purpose, to show, look, we're all human. And there are some certain elements of morality that apply to all of us, regardless of the country that we're from. And there should be certain things that should not be done. Let's just talk about what those are. Because efficiency that throws humanity to the wind is monstrous.
Any more questions? And did you want to address?
One thing I'd say is I think there has to be some type of balance, right? So I think that when we, you know, thinking along the lines of data, like the data privacy, I was thinking quite a bit about that, because some of the data we use, it's like people can opt out, but they don't have to opt in, right? And in certain states, like your electronic health record can be used for research. You don't have to consent directly. And we use it to try to learn, right? But as we use it to try to learn, we also make promises and set up structures to try to protect that data, and protect that information. And we have, rigorous rules about where it can be held, where can it go, where can it go. So like there's this balance, I think, between, trying to make sure that we're responsible and good stewards of information and data that we have, but also trying to think about how we balance with the rules that are in place. And then I guess the last thing I would say is that when we talk about an efficient model, that if the model is efficient but bad, then we haven't done something great because we got it to market quickly, because we got something to market that wasn't terrific. So if I'm the person or the modelers who developed the facial recognition software, and then X years later, now people are talking about that facial recognition software that wasn't accurate and had poor results, that's not a great thing for me as the modeler, right? That wasn't my intended consequence. And so I think that efficiency has to go together with quality, right? And I don't think that these rules are independent of quality, right? It's kind of trying to put those two things together.
That makes me think a little bit about education as well. As we're raising children, what expectations do we teach them to have about their own rights, about their own data, and about their own privacy? And would at some point that be a part of elementary education, right? To understand your own data rights and your own data privacy. I don't think that's been, civics are very much not a part, I think, as much of our elementary education as they used to be. And it's interesting to think if this might be a way that might come back in.
While you're going to that side,
yeah.
I would argue that that's true for our academic children that we're actively producing right now, that really we have to be responsible for how they are as modelers, how they live in this system where this AI is present, how they learn, how they develop, what rules they use, how they interrogate the models and structures that they develop. We're responsible for that, right? And so how are we training them, and how are we helping them to think through this is really important.
Yeah, and maybe I shouldn't have said elementary, and maybe I should even say our undergraduates, right? Our graduate students, how do we have all of our, and ourselves, how do we educate ourselves about what our rights could be, what they should be, what we want them to be?
Hi, thank you all for your comments today. This is a question for anybody on the panel, and it is how specific should the rules, principles, or laws that we implement be, because AI is rapidly changing. It's able to do new and wondrous things on a yearly, monthly, daily basis. We can't really project exactly how much information it'll be able to get from us. For example, when it comes to privacy, in a year or two from now, new techniques will be developed. So should the laws be very specific, or should it remain more in the realm of soft law, and exactly what form should that take?
This has to be for me. Yeah, interesting question. So, to give you an answer, one of the things, and it's in our discussion here, Julie and I were talking about this, one of the things that we have to start thinking about is the role that the technology plays in forming the law itself. There's a whole different groups of philosophers now who look to think about social systems that also include technology, and the technology has agency in the system, right? So we have to think about administrative agencies nowadays are using artificial intelligence systems to make decisions. They're also generating regulation at an enormous rate, right? Now I have friends who practice in administrative areas, and they have to check the rules in the morning and in the evening to see if anything changed. This is a time of really rapid change. So I think that's really, really interesting. Our understanding, one of the things that I see in listening to the panel as a legal issue, but also sort of very practical issue, is this idea of consent. And I think it actually also fits in with thinking about how we educate children. All of these regulations about privacy, the use of data, anticipate consent, right? Getting consent, as though getting consent cures the problem. And I'm not sure that it does, particularly in an age when contract law itself is less focused on consent. Let me ask you, how many of you clicked on a contract today and accepted it? And how many of you read it, right? And yet we have a contract system based on consent, and we're creating this data privacy system based on consent when we all kind of wink and nudge and say, consent's an illusion, right? So this becomes a problem too. So I think the legal field needs to, we need to really start from ground zero and rethink so many of our principles now.
Thanks. Rich questions and rich answers. So we're at the end of our time. I want to thank you all for participating with us. We'll be around to talk more, and stick around for the rest of this day. It's going to be really awesome. Thanks. Thank you, panel. Thank the panel.
Thank you, Ray. Can I ask, at this time, can I have our lightning round, faculty lightning round presenters come to the front here for the 2 to 3 session? And we're going to move a couple things on the stage. So I'm going to meet with you just a second. Okay. Oh. I'm going to share. I told him it was a song. Right. Okay. What a great first informative discussion we had for the panel. Thank you. Special thanks to Ray and our panelists for an engaging conversation on really what is a sensitive but very timely topic. In this next section of our agenda, we get to hear from our faculty, and we're giving our chance of faculty to showcase their research and provide a platform for the NC State community to discover research across campus. The presenters will only have 2 minutes to present their research or scholarship that is relevant to any aspect of data science or artificial intelligence. Following our first 6 speakers, we're going to take a very quick 10 or so minute networking break. So don't hesitate to connect during that time to a speaker that resonated with you or something you want to learn more about. In our first block, we're going to have 2 separate 10 or 15 minute sessions of lightning round presenters, followed by a quick networking for each. And then we will have a third group that are coming later in today. I did want to note for the group, it's award season, right? We're kind of in an Oscars and Academy Awards here. So we do have a timer. Okay, so, oh, sorry, this is tropical. Hold on. Okay. So if you hear that as a speaker, that means your time had come to a close, and you have to say your last 2 seconds of slides. There is an advancer up here, and I'm going to reset this. All right. I am going to ask our first presenter to come up to the stage, Benjamin Reading. I am not going to do the transitions after, and we're just going to follow through to the next person, so make sure you introduce yourself and then move on to your slides. All right.
Excellent. Thank you, and good afternoon, everyone. I'm Ben Reading. I'm an associate professor in the Department of Applied Ecology. These are 4 of my recent graduate students who have graduated, and they've had artificial intelligence or machine learning as part of their curriculum and training here at NC State University. Briefly, I work mostly with, this advances. There you go. I work with aquaculture fish farming, fish physiology. I'm a breeder. I work with genetics. And so we use artificial intelligence to predict the phenotypes of animals. And so this is part of the G2P, or Genome to Phenome Initiative, authorized by Farm Bill 2018. We do a lot of work with genetics. I am the co-coordinator for aquaculture, and I'm also the national chair of the NRSP8 for USDA. This is the National Animal Genome Program. The goal of that program is to create genome resources for all agricultural animals in the country. And we use then machine learning analyses to look at things like genetic variation and gene expression levels to predict the phenotype of those animals. And in this particular case, I work with fish. We do congruent work with academic, industry, and government partnerships. So the fish we breed, for instance, go into industry and then are raised commercially. And so we address challenges for seafood security for the United States of America. And so we promote domestic U.S. seafood production. And lastly, I am a content matter expert for U.S. intelligence. I work with U.S. Department of Homeland Security on threats to food and agricultural resources. Some of the major considerations there are artificial intelligence, as well as then the accessibility and integrity of databases such as genome sequences of animals for the country. So with that, thank you, and I'll introduce the next speaker. There.
Hi, everyone. My name is Roland Kays. I'm in the Department of Forestry and Environmental Resources and also the North Carolina Museum of Natural Sciences, where I run a lab. And I'm going to be talking today about images that we get from camera traps. So this is a motion-sensitive camera trap. An animal walks in front, and it takes a series of pictures or videos. It's really great for monitoring wildlife because you can count the animals as they walk in front of the cameras. You can compare how many animals you have in different places. Especially a lot of the questions we're asking is, how are they dealing with humans, or how are they not dealing with humans on the landscape? That's the type of questions that we're asking. And we're now running thousands, sometimes tens of thousands of cameras. We started a national mammal survey called Snapshot USA that has cameras in all 50 states with hundreds of collaborators, which of course is generating millions of images. We do it every year, so we're getting millions and millions and millions of images. We've also worked with a team of collaborators from NGOs to create a tool called Wildlife Insights that has some AI to help identify species that's getting pretty good. We work with Google on this particular project, so they're helping with this. But there's so much more we could do. And so what I want to kind of use my second minute for is to talk about some other things that we might get out of these pictures. Look at this weasel. He's totally screwed. He's white, and it's brown. There's no snow because of climate change. And so we can start to quantify the camouflage and the mismatch by cropping the animal out and looking at the color of the background and the animal. Look at this deer, obviously sick. But we have no tools yet to identify these. But we've got now millions of images that we could be mining for looking at animal health across North Carolina, across the world. And these are some projects that we're just kind of messing around with in my lab. I'm a biologist. I'm not an AI scientist. So certainly looking for collaborations for these kinds of things. So thanks. That's all.
Hi, my name is Phil, and I'm a chemical kineticist. I'm a chemical engineer, but I'm a chemical engineer who wants to find out how fast reactions go for renewable bio-oils, for fire-safe aircraft interiors, for destroying PFAS chemicals. We've got tools, particularly this extraordinary two-dimensional GC time-of-flight mass spec, that are great for identifying species. Quantifying is another problem, and to really solve problems, we need to have quantities. So my grad student and I turned to neural networks to try to do it, because the standard way of determining how much is to have an authentic sample, and we're seeing species that have never been observed before. You can't just stick them in the machine. So what we've done was predict calibration factors using a neural net. The principle that you get a peak out of a GC mass spec is that it ionizes molecules, blasts them into fragments, you count the number of fragments that are there. That's great if you've got an authentic sample, shoot it in, measure how big a peak. We don't have that. But we went to the fundamental physics of the electron ionization cross-section, said if we can predict that, we can deal with these new compounds that we've never seen before. So we developed a database, the largest database today of these cross-section data, used MATLAB with some of the tools it has to do a feed-forward neural network model, developed the descriptors to describe what's in molecules so that we could do the predictions, and it was remarkably successful. The third image over there is showing the prediction. It's not perfect, but it's enough that we can get quantitative results and answer some of these questions about the key reactions we want to understand.
All right. Hi, everybody. My name is Adriana San Miguel. I'm an assistant professor in also chemical engineering as Phil. He's my colleague. And in my group, we work with a little worm called C. elegans. It's a really good model to study multiple things. In my lab, we use it to study aging and neurodegeneration. And we do some work also with microfluidics, which is what you see here at the bottom. And that's useful to handle these worms in a really high throughput fashion. We automate our experiments, and we can sort them, trap them, expose them to different conditions in a very well-controlled manner. When we incorporate all these systems, what we can do is can get imaging data really quickly. And because these animals are transparent, you can look through tissues in a live organism. So that's where machine learning and deep learning come in. So here's just a few examples of the images we take in my group, and in all of them we've used machine learning to analyze these images. So we really try to get quantitative information from these images, and just to show you some examples, in the top we see stress granules that we use as a biomarker for aging, and this quantitative data was then used to find genes that modulate aging rate. So we have some new genes that can make animals live less or more. At the bottom, you have neurons from young and old individuals or worms, and the morphologies we see in neurons are very complex and difficult to analyze. So this is where, with our collaborator, Kevin Flores from the mathematics department, we've developed tools based on deep learning to analyze these morphological changes that are indicative of neurodegeneration. And then the last image over here is showing you how we can predict lifespan of a worm just based on the information from the activity of a single gene. We developed a reporter, and we use machine learning to analyze that.
Yeah, hello, good afternoon. My name is Paul Liu, and I'm a professor from the marine science. I know I only have 2 minutes, but I still want to use this opportunity. Thanks, Laura. Thanks, everybody. Organize this wonderful workshop. Yesterday, after hearing Dr. Josh Gray to talk about AI application on the remote sensing, I immediately sent him an email. This morning, we have 1 hour coffee time. We have so many ideas come out, and collaboration and a proposal. Thank you again. Wonderful. Now, 20 seconds past. So we are in an academic field. We know the very famous saying, publish or perish. Everybody had to publish if we want to survive here. But we know how headache the publishing process. Review, rewrite, particularly if your language, the native language is not English. There's a lots of headache. It's a challenge. So we, in order to solve this problem, I'm an editor of 4 international journals. I have so many international students and scholars. I know how difficult, even myself. To solve this problem, we used published data, 10,000 PDF paper, and put them together, fine-tuned GPT 1, 2, and 3. Here it is. For example, if you put this text, and within just 17 seconds, the rewriting without any grammar error come out. And even more, and for example, I just put Laura's message here. You can see the rewrite after Laura write a perfect English, but you can do a different style, different tune. And also, you even can put, a different language, like a German or, different language here. And, or you can translate it to English to any other language. So, so far, this is only test only. If anybody are very interesting to test this program, can save you a lot of time to rewrite, and to a perfect scientific English. Okay, thank you.
Thank you, Paul. And actually gives me a great segue. So all of our Group 1 presenters are standing stage right over here in case you'd like to take a couple minutes to talk with them and hear a little bit more about their project. Before you get up, we're only going to have about 10 minutes, and I am going to ask you to get back in your seats, and we will have more time for networking later. One of the things I want to mention about networking facilitation, now that we have more faculty in the room, we have a facilitated discussion this afternoon at 4 o'clock that is going to be a great opportunity for you to really get to know even more people in the room. What are some ideas that have been generated, things that you've learned throughout these 2 days? And I think it's going to be a really great tool. I mean, to Paul already making connections, I love to hear that, but I really think this 4 o'clock discussion and facilitated discussion is going to allow even more of those discussions to take place and really get everybody in the room to know who's here and what we do at NC State. With that, part of the facilitated discussion is going to utilize something we asked you to do when you came in today, which was self-identifying yourself into a category of data science and AI research. If you have needed some time to think about that, there are a couple stations over here by the break service. There's one in the back table, and there's another out at the registration table. If you've thought about it now and need to change your self-identification or need to add an additional category there. So with that, let's give ourselves about 8 minutes, and I'm going to get back up to ask you to get back in your seats. But your first group of presenters is right here to stage right, and we'd love for you to get to know some of them and ask them a little bit more about their research. So. All right, folks, I know 10 minutes isn't at all enough time, but I'm going to start asking you to get back to your seats. If you're a group 2, if you're part of my group 2 speakers, presenters, please join me stage left, and we'll get lined up, and we'll get started here in just a second. Oh, no. You're, hey, Walker. Cheryl, is this your first? Oh, Yin-Chen, this is your first slide, correct? Okay. Everyone got real quiet. Well, I guess we can start because we're getting really quiet. You have an advancer, or you can go forward here. Okay. Oh, okay. Well, since everyone got so quiet, we are going to start our next round, and I'm going to ask our first presenter, Dr. Yin-Chen He, to come on up and take the stage.
Good afternoon, everyone. My name is Yin-Chen He, and I'm an assistant professor in the Department of Psychology. I lead the Translational Vision Research Lab, where we use knowledge about visual perception and human factor psychology to solve real issues faced by people with vision loss. So my first goal here is to maximize the efficacy of visual interfaces even when the visual input is reduced. And this includes not only people with visual impairment, but also for those who are in suboptimal viewing conditions, for example, driving in a fog, or working without glasses, or even astronauts in space because their eyeballs change shape due to changes in gravity. And my second aim here is to improve vision by designing training protocols or designing care plans to manage disease and also to optimize medical devices such as retinal implants. And lastly, I also study how to most effectively deliver information in non-visual ways, such as using hearing and touch. And I also study how does reduced visual input affect multisensory integration. So incorporating data science and AI into vision research opens many new exciting doors, and I am eager to collaborate with like-minded folks here today. So for example, by analyzing large amounts of patient data, we can design personalized treatment exercises or prescribe tailored medication dosages or use predictive modeling to monitor disease progression. And by exploring data visualization and physicalization ideas, we can engage individuals with with diverse abilities to benefit from a multisensory experience. So ultimately, my goal is to improve people's quality of life and achieve universal design. And I believe this can be revolutionized through data science and AI. Thank you.
Hi, I'm David Lalish from Biomedical Engineering, and I work in medical imaging research with human subjects. a lot of the AI development over the last 30 plus years has been driven by the diagnostic radiology application, basically trying to replace radiologists. But that's not really what I want to talk about today. These are a couple of examples of projects where we're using AI methods as tools as part of a kind of larger protocol in research. So in one of our projects, well, in dealing with human subjects, one of the biggest problems is humans. We're all different. And so in one of our projects, we're doing combined PET and MRI imaging of the brain using a PET tracer that's sensitive to inflammatory activity in the brain. And this is very sensitive to genetics, it's sensitive to individual metabolism and so forth. And so one of the issues that you confront in dealing with these kind of things is how do we kind of use an internal control, which you generally use in PET imaging. You find a region that you can use as a control. But that's very difficult with this particular tracer. And so what we're doing here is actually using a neural network to examine the time progression. This is dynamic PET, and unfortunately I put a movie that I can't seem to work from this situation. Maybe not. Anyway, but this is a dynamic tracer, and so we're actually imaging over 90 minutes and watching how the tracer goes into different parts of the brain in our four-dimensional images. And so by tracking different regions and what their time activity curves look like, we're actually using a neural network to examine which are good candidates for reference regions. The other one I want to mention is actually an orthopedics project. So everybody's knees are different, certainly. In fact, your two knees are very different anatomically. And so trying to do longitudinal studies even with the same knee, where the knee at two different imaging sessions might be in a different conformation is a challenge to kind of match up that data. And so we're using deep neural networks as part of that process in identifying the bones that allow us to register bones rigidly and then allow tissue to deform around them, which makes it a much more realistic approach. And so, well, these are some of the examples. I kind of have a long-term dream here of using this to standardize knee imaging in the same way that we've standardized brain imaging over the last, say, 20 years. So, thank you.
Me. Let's see. There we go. Hi. You're going to start? Okay, good. I'll keep in 2 minutes. I'm Bill Ditto. I'm professor of physics, and I founded the Nonlinear Artificial Intelligence Lab about 4.5, 5 years ago. Our mission is to advance and push state-of-the-art of what artificial intelligence can do with an ultimate goal of generalized intelligence. First question we asked was, does artificial intelligence understand, can it detect, can it see chaos? This is a field I've worked in many years. It has impacts in many applications all across the board. The answer is absolutely not. It's really bad. When we did it, what we found was, and I'll just show you the kind of the key plot which we put in our patent, is if you look at the green dots, that's what a regular neural network will do. Our new type of neural networks will actually find chaos, reproduce it, and be able to analyze it, control it, manipulate it, and everything in between. Since it's one of the organizing principles of nature, we're very excited that we're able to do and recreate everything we've been doing over the last 30 years in about a year, and now it does it in under 10 seconds. So it's a whole new world out there. Next question we asked, which was actually of societal interest, was there's a lot of debate about diversity in culture, diversity in biology, and all across the board. Does diversity convey an advantage? I think in biology we see many cases, in ecology many cases, and proof of this. Would an artificial intelligence choose diversity over homogeneity on its own to prove that principle in a very different venue? And the answer is absolutely. Not only does it do it, so by choosing diversity, it chooses to change its individual neurons to different neurons and how it computes. This also has enormous commercial impact, but it also proves the point is diversity is strength. Artificial intelligence will choose it, and we can actually utilize that in many different applications, power grids, avionics, all across the board. Thank you.
All right, hi everyone. My name is Sean Mankad. I'm an assistant professor of analytics at the Poole College of Management. And I'll also mention this is my first year here at NCSU, so I'm super excited to meet everyone. And my PhD is in statistics, and I'm going to tell you about two kind of types of data I typically model and work with. But I'm always looking for new data sets, new collaborators, new problems to work on, so looking forward to the discussions. The first main type of data that I tend to work with is networks. And you just saw some cool pictures on the previous deck of cool networks. Typically, I'm working with financial networks. So you hear in the news all the time now that, hey, if one bank goes under, this is going to create financial distress at another bank, and it's called the contagion in the banking sector. And contagion kind of reveals that right now in finance and economics, the view of the world is very much driven by networks. And it's saying that, hey, these two banks are somehow connected in some abstract way, and then when this, financial distress of one bank is actually being transmitted to the other bank. So I'm working on techniques to basically estimate the network and then come up with new risk metrics. We use techniques from statistical physics, from social network analysis, as well as just, I would create like new dimension reduction techniques, so things like matrix factorization and such models. The other big type of data that I work with is text data. So being in a business school, oftentimes I'm looking at like customer feedback and things of this sort, or financial disclosures. But here, if you're interested in doing things like sentiment, topic discovery, trying to do sentiment, topic discovery, and along the lines of regression or causal inference all at once, this requires kind of a unified model of how you're looking at text and bringing in external covariates and things. So this is another big type of data for me, and if you have some interesting applications or problems in these two data sets, I'd love to discuss. Thank you.
Ready? Okay. Hi, I'm Hamid Krim. I'm from electrical engineering, and my thanks to our students. Actually, a lot of our work sort of navigates from basic to application, depending on who's the sponsor. But the whole theme, though, is AI and machine learning and intelligent signal exploitation for data to decision, and of course, exploitation. And that includes deep data structure-driven multimodal information fusion and exploitation. And in network sciences, we look at autonomous sensing networks, as well as sensor, as well as social networks. And we have some applications as well, where the data analysis as well as decision is essential for surveillance, inference, and health assessment. Of course, for exploitation, just as an example here, one has to be able to both parse the data from where it is to subcomponents, such as here, for instance, taking a video sequence and being able to parse it into the fundamental blocks so that one can actually exploit them, as well as being, as well as being able, of course, to put these things together and be able to fuse the information, put it together, analyze it, and be able to exploit it and make a decision. That's about it.
All right, good afternoon. Can you guys hear me okay? All right, so my name is Lokendra Pal. I'm a faculty in the Department of Forest Biomaterials in the College of Natural Resources, and really glad to be here. I have a couple of projects working around the AI and especially focusing around the smart sustainability. One of the projects I would like to highlight today is AI-enabled hyperspectral imaging of municipality solid waste to be able to characterize deeply and then upcycle to various like bioproducts as well as biofuels and biochemicals. Now, let's a little bit talk about what's the motivation for these projects, right? So if we think about the waste that we generate, for example, the coffee cup here, we'll drink, we use for a few minutes, it will going to go into the trash, and then it will be somebody will haul it to the landfill. We have over 2,000 sites across the United States landfilling close to 150 million tons of these materials, right? And then the issue is, of course, land usage and all, but the biggest thing is the third largest emitter of the methane, 17% of all the methane generated in United States. Then also, it has a lot of organic. This cup have really high quality fibers, right? So if we can characterize it, we can separate it, and then be able to convert, that will be really exciting. So that's the motivation. What we're trying to build, think about the, really one of the largest data repository in terms of the visual imaging, hyperspectral imaging, be able to do the labeling, make this data searchable, available to the citizens, and not only to the citizens, but also the researchers across the United States, across the world, and then be able to really do like MLs, AI, and then finally be able to make some decision in terms of what material could be used for what pathways, such as like fuels or bioproducts. And lastly, I would like to highlight here, just quickly, we're going to be organizing a conference, just focus on this waste to advanced resources, August 9th and 10th at NC State. A lot of partners, DOE, NRELs, National Labs, as well as here, all the people here participating, I'd like to invite for that conference and be part of this journey. Thank you.
Hey, good afternoon, everyone. My name is Cheryl. I'm a professor in mechanical and aerospace engineering. This one topic is, it was founded by Air Force. We were also funded by the CIF a couple of years ago. It's a NC State Chancellor Innovation funding. The topic here, I'm really looking for collaboration or help from the audience if possible. Is one kind of material composition and fabrication modeling. If you know of the material, have some basic understanding, is the material that we are working on is a composite material. It's a ceramic material. So as you can see from the lower left graph, we have reinforcement and we have matrix. The combination of the loading and the size and aspect ratio of everything will affect the performance. The performance we are looking for specifically for this project is for the radar absorption performance. So it's one kind of electromagnetic property of the material, everything. The main guidance for this model is that you have some parameters that you can tune, like materials, compositions, sintering temperatures, those things that you are controllable. The reinforcement that you see from the previous graph is generated in situ. And the block diagram here on the right-hand side is the output from the modeling. Specifically, what we're looking for is the return loss. This return loss means how much energy you can be detected by others. We want to minimize the value as much as possible. And on the top of it, it's also a function of temperature and frequency as well. And there are standard rules from electromagnetic textbook. The physical model is there already, but it's not directly usable for us. So we are looking for some digital tuning to combine these two types of models together. So if there is any interest, we look forward to collaboration. Thank you for your time.
Okay, thank you. Similar to last time, we do have a couple of minutes for some networking, and our group 2 presenters are over here stage right. I'll do another plug for our facilitation that's going to happen at 4 o'clock today. Just another chance for all of these connections to happen. If you've been curious about the paper that's sitting on some of the tables, that is what we'll be using for that collaboration. And you'll see a couple of them hanging on a couple of the empty tables that are over by our break service area. But with that, we'll have at least 10 or 15 minutes to come and network, either with our, hopefully our presenters from Group 2, but also I know many of our presenters from Group 1 are here as well. So go ahead and get a cup of coffee. A great time. Restrooms, if you weren't here earlier, restrooms are across the hallway in the yellow alcove. And again, if you haven't self-identified yet, or if you think you need to add something to your tag, there's a couple stations you can do that by the break service, at the registration table, and there's one to the far left, rear left. Thank you. so I just... All right, everybody. Let's go ahead and take our seats. We're going to move on to another piece of our agenda today, and we're going to hear from the Proposal Development Unit. I didn't bring my paper up. hold on. Wow, they're Don't worry, we have plenty of more time for networking today. So this was not your last chance to meet those presenters that you're networking and collaborating with right now. So at this time, I'm going to welcome Molly Puente. She's the Assistant Director of Life Sciences, Health, and Agriculture in the Proposal Development Unit. She's going to provide us an overview of identified funding opportunities in data science and AI and discuss resources available to participants when pursuing these types of RFPs. So Molly, I invite you up to the stage.
Okay, thank you. Okay, so I just wanted to start with a quick introduction to the Proposal Development Unit for those of you who may not know us. I'm excited to see a lot of folks that we've worked with in the past, but for those of you who may not work with the PDU before, we are part of the Office of Research and Innovation, and our group provides sort of a deep touch for really complex proposals. So we typically work on large team projects where there are people from multiple colleges. Typically, these are projects well over $1 million and into the $10 to $100 million type of range. And what we do is provide everything from facilitation and team management to helping with the writing of non-technical sections. We help with budgeting, pulling information from partners and subawards, and also helping coordinate projects, pulling all of the information for CVs and biosketches and things like that. So if any of you are looking at any of these opportunities for large centers and networks and saying, I would need help if I wanted to go for that, you can come to our website and request support. In addition to helping teams one-on-one, we also have a lot of resources available on our website. So you'll see these icons to click on PDU resources, and if you go into that, it asks for an NC State login. But once you get in there, we have all of our past presentations. So if you're interested in information about the NSF Career Award Program, if you're interested in NIH presentations, our slides for this presentation will also be kept here. So if you're interested in grantsmanship information in general, this is a really good spot to look for. So with that quick introduction to the PDU, we wanted to talk specifically about funding opportunities for data science and AI. So thinking about the federal landscape, one of the things that the PDU likes to do is take a look at what's being talked about at the legislative side of things, as well as in the executive branch side of things, because you need to have an alignment of both what's going on in Congress and what's going on in the White House to really see things happening in terms of funding coming down. So if we think about what's going on in the Congress, one of the acts that we were looking at was the National AI Initiative Act, which came out in 2020 and was really inspiring the agencies to think about more R&D and training funding for researchers who are interested in AI. And this was kind of rolled into some of the language in the CHIPS and Science Act as well. So there's definitely an interest in Congress to support these types of things, especially thinking about it in terms of workforce development and training the U.S. Workforce. And then we take a look at what's going on at the White House level on down, and we see that the White House sponsored this National AI Research Resource Task Force, which was co-led by the NSF and OSTP. And they recently put out a report in terms of this idea for a national AI research resource. So to kind of dig a little bit more into what that would be, this would be a plan to develop a national resource that could be used by academic groups, by nonprofits, a large area for folks who are interested in artificial intelligence research. It would be developing data tools and resources for people interested in this. This was kind of pitched as kind of an on-ramp to help more groups get involved in AI research, because there's this perception that generally research-intensive institutions are already on board with what's going on in AI studies, but it's really hard for organizations who maybe don't have a lot of resources available to even start or know how to get involved. So this was one of the ideas behind this Research Resource Task Force. So we anticipate that the calls will be going out soon to get this stood up. It sort of depends on what the FY24 budget is going to look like for the National Science Foundation, but this is one of the things that the PDU is keeping an eye out for something that may be coming. And we anticipate that should this get rolled out, this would also probably have a lot of impacts for other agencies such as the Department of Energy, Department of Defense, and NIST. So when we think about where AI research is happening at the federal government, oftentimes our first area to look at is the National Science Foundation. We think a lot about the SCICE Directorate because that's where a lot of computer science and engineering is happening. And we do see a lot of opportunities coming out there. So they recently had the AI Institutes program. That call has actually closed now, so the last proposals were due in 2022, but we are keeping an eye out for if they decide to do a second generation of that. There's also opportunities for the Expand AI program, and this is interesting because it kind of falls along that same idea of how do you expand partnerships to bring in researchers who may not come from these rich areas who are interested in getting into AI type of research studies. We also see some of the other directorates looking at AI as a way of the future. So the Centers for Chemical Innovation, it may not seem obvious as an AI type thing, but one of the research areas that they're looking at is cheminformatics and how to bring informatics into chemical discovery. We also see some of the long-standing programs at NSF, such as the Engineering Research Centers and the Science and Technology Centers, including bullet point language about how potential areas of research that could be pursued in some of these large interdisciplinary centers should have some sort of machine learning, artificial intelligence, data science aspects to that. So we're keeping an eye on some of these long-standing programs as well as areas that could develop this. In addition to the centers and networks which the PDU tends to look at, there's also a lot of resources available for individual investigators who are looking at other levels of projects. So here we've highlighted a few. Some of them are coming out of the SCICE Directorate that are very focused on data science types of topics. So for example, we have the expeditions in computing, which you can easily imagine how AI topics can fit into that. But we also see that there's interest in bringing in other kinds of fields. So if we take a look at the last one on this list, the smart and connected communities. It's not just about developing technology, but also thinking about future user groups. So any of you guys who are interested in sort of the social sciences and how those might be linking into how these technology networks are getting rolled out, that could fall into the smart and connected communities call, for example. So in addition to funding research, the National Science Foundation is also heavily engaged in workforce development and training. So they have several programs at different levels. At the graduate level, there's the National Science Foundation Research Traineeship Program, the NRTs. There's also the RU program for undergraduates, as well as the IUS program. I guess one thing I want to just warn folks about, so we posted what the deadlines are for these, but it's important to note that a lot of these training programs are limited submission, which means NC State is only allowed to submit 1 or 2 applications, and therefore it's important to look at what the internal deadlines are for these. So for example, if you're thinking about an NRT program in the area of artificial intelligence or machine learning technologies, the call for internal submissions to be one of the NC State slots has already passed for 2023. So you need to start thinking about 2024 at this point. The same is true for the technology instrumentation programs, the MRI programs. So those are also programs where the due date is far away, it feels like, in November, but the internal deadlines are going to come soon. So if you're interested in developing the instrumentation programs that you may be needed to pursue a machine learning type of program, you'd want to take a look at what that call is and think about it for basically a year in advance. So that's the National Science Foundation, but they're not the only game in town who's looking at this. And as we heard from several of the lightning talks, okay, we have a question? Okay, so a question that we received is, about whether the NRT program, how does that work for multi-institutions. So that's probably best answered by reaching out to the limited submissions office. They can answer questions about that in general. For that specific program, the way it's written, both institutions would have to use up one of their 2 slots. So that's how that works. Okay, so switching gears to the National Institutes of Health. So we heard at the lightning talks earlier today a lot of topics that were health related in lots of different ways that they're looking into integrating artificial intelligence. So what we're seeing is that the institutes and centers are putting out calls of special interest specifically for topics about this. So for example, here I've got a call from the National Institute of Mental Health looking at trying to use AI to understand behavior, and a call from the National Cancer Institute, which is looking at this at more population epidemiology, surveillance types of questions. So in addition to specific calls for research projects, there's also calls for training topics. So there was recently a T32 that was looking at integrating artificial intelligence for precision nutrition studies. So that's pretty specifically looking at trying to develop AI expertise within biomedical research. And like NSF has the MRI program to develop instrumentation, NIH is also thinking about research resources. So these would be projects that don't necessarily have a research question, but are developing resources that could be used by a broad community of researchers. And what's really interesting is they have a program that this PAR is going to be reissued in the next couple months. So they put out a notice of intent to publish a new version for biomedical knowledge bases, so as well as biomedical data repositories. So if you're thinking about developing new data repositories that could be structured in such a way that you could apply new technologies of AI and new techniques, this may be an interesting RFA to look at just to get a sense of what they're looking for to develop a resource as opposed to doing a specific research question. And for those of you who maybe have worked with NIH in the past, you'll know that actually the majority of applications going to NIH don't go through these specific calls that are topical, but actually come in through the investigator-initiated proposals. So there are several home institutes at NIH that have actually expressed in their recent strategic plans an interest in developing AI expertise. So one is the National Institute of General Medical Sciences, and this one institute has the biomath portfolio. So if you're coming at it from an algorithm development type of angle, NIGMS may be your natural home. If you're coming from more of an engineering background, you may be looking at the National Institute of Biomedical Imaging and Bioengineering. And if you're looking at it from, say, an ontology development and thinking about the terminologies and how you're structuring databases so they can be searched, the National Library of Medicine may actually be where you want to look for, which is interesting because most people don't think about applying to a library to do data science, but that's exactly where it's housed at NIH. If you're looking at applications and how AI is going to be applied to clinical and translational settings, NCATS has a program that they're interested in seeing R01s come in that area. And then finally, NIH has set up an Office of Data Science Strategy that's part of the NIH Office of the Director, which can provide supplemental funding to all of the institutes to fund data science types of topics. And an example of this ODSSS funding is this notice that we have here at the top, which is administrative supplements to support collaborations to improve the AI ML readiness of NIH-supported data. And I wanted to call this attention to anybody in this room who may actually already have NIH research in any topic, right? So you could be studying regenerative medicine and looking at cell tissue cultures, right? But the question is, would your data collection be improved by working for, say, a semester with a data science expert who could help you harmonize your data so that it could be applied as a training set for some other AI system? So these are supplements. So you've already started your project, you could get a supplement to bring in that expertise for a data scientist to come in and work with you to improve your data so that once your project is over, you could share your data or apply it to other systems. So it's kind of an interesting program where they're trying to foster new teaming midway through an existing R01. So this may be one of those resources that you guys can use and talk about during the networking sessions later. In a similar vein, the Parent R03 is designed to be a small research grant. So maybe you've already collected data and want to work with a new partner to analyze it in a different way. So these are meant to be short-term, say half a year-long grants, where you're just kind of taking a new look at existing data. So consider these as opportunities. So our charge was to talk about funding opportunities, but we also wanted to think more deeply about what kind of resources are available from the federal sector that may help people who are interested in doing this kind of research. One of the things that has come up from a lot of different agencies is the idea that data sets are getting so big that we need to start thinking about how people are accessing the cloud to do the computation. So different agencies are taking different approaches. The National Science Foundation has negotiated something called the Cloud Bank system. It's an interesting program, so you'd have to kind of talk to your program officer ahead of time before you actually put it into your application to make sure it makes sense to apply. And what it would do is you'd still have to budget the cloud structure into your costs, but you wouldn't have to take F&A costs because NSF would cover the F&A if you use your cloud services through the Cloud Bank for any NSF grants. In a similar mechanism, NIH has something called the STRIDES mechanism, where they've basically negotiated out discounted versions of using the Google Cloud, the Amazon Cloud, and the IBM Azure Cloud. So if you're already thinking about using one of those cloud services, it would be worth reaching out to the Office of Data Science Strategy and seeing if you're applying for an NIH grant that falls under one of these programs, if you could actually get discounted use of these clouds for doing your data processing. Additionally, one of the things we talked about during the first session today was about trustworthy data sets, right? So thinking about why do people trust data or not, and understanding where the data comes from. And so one of the ways to think about developing data AI tools that people trust is using training data sets that other people can verify. So using publicly available data sets that other people can use and think through, and so that it's not kind of private data. So a lot of the agencies are thinking about trying to put out already curated data sets in various places, right? So for NIH, there's basically two big places that I want to kind of draw your attention to. So their Office of Data Science Strategy has actually put out a list of all data repositories that NIH has paid for that makes data publicly available. And this could be the import data that's on immunology data from NIAID. It could be the NHGRI Anvil data for human genome data. So they just have this repository of repositories that can be very useful for trying to identify data sets that meet your needs if you're looking to test data but not collect it from scratch. Additionally, they've invested a lot into these common fund programs. These are sort of NIH's big projects. So these are things like the Human Genome Mapping Program and the 4D Nucleome Program. And so all the data they collected from these really big investments in the common fund, they've actually now put into this data ecosystem, which is trying to build these data sets so that people can do secondary analysis on this. So I'd encourage you to check that out. If you're thinking about how you develop tools, but you don't want to collect the raw data, this could be a really good way to do that. The US government has actually tried to put a hub for all data. So if you could try looking at data.gov as another good source for looking at publicly available data that could be verified by other sources because it's out there and in the public sphere. So last, we wanted to talk about some of the other agencies because we didn't want this to come across as just being NSF and NIH. So even though those are the two big agencies that a lot of folks at NC State gravitate towards, there are a lot of agencies that are currently thinking about how data science fits into their mission. So some of the ones that we wanted to highlight, first, the Economic Development Agency, which is part of the Department of Commerce, is coming out with a regional technology and innovation hub. So they put out an RFA call this March, basically asking folks to suggest topics, right? So that process has gone through, which means the next step is they're going to put out the call for proposals. So this is the perfect time to start thinking about how you would develop a regional technology and innovation hub. And these EDA programs often kind of combine research with also thinking about workforce development and how you're going to use it to improve the current economic climate for a region or an area. The U.S. Department of Energy has Energy Frontier Research Centers. So this is a program, if you're just trying to look for it now, it would look like nothing's going on. But in fact, this is a program that has competitions every other year, right? So the 2022 cycle went through. Nothing's going on in 2023, but we anticipate that 2024 is going to be the next time that they recompete these energy frontier research centers. And as we heard from several of the lightning talks today, areas in energy are one of the areas that they're interested in, and thinking about reducing greenhouse gases, thinking about kind of the energy efficiency. For those who are interested in Department of Defense programs, they have the multidisciplinary university research initiatives. These typically follow more of a white paper and then being invited to submit a larger proposal. So here we have the Office of Naval Research, which has a white paper due date coming up in May, but each of the armed services has their own program with that. So the Department of Transportation, in their latest calls, have indicated that they're interested in looking at data science approaches to thinking about transportation issues, whether they're aviation, thinking about traffic flow, pedestrians, things like that. So they're looking for university transportation centers. One thing that's interesting about the DOT program is that they're divided into regions and only compete certain regions in certain years. So this year's region is the Western region. So this is probably not for us, but when it comes around to our region again, if you're thinking about how you can apply AI to transportation questions, this would be sort of the largest funding pot coming out of DOT that could cover that. One program that we're really interested in is the DARPA AI Forward, and this is still very much in the kind of incubator staging. So they're actually going to be, DARPA's program officers are going to be hosting virtual events coming up very soon throughout the summer. So if this is an area that you're kind of curious about DARPA and want to learn more, they're going to be holding these technical workshops that you may be interested in attending virtually or in person. So you can go to their website and learn a little bit more about what this AI Forward program is looking at. And finally, we do want to say that there's a role for humanities in the question about data science and AI. So the National Endowment for the Humanities has published the Dangers and Opportunities of Technology Perspectives from Humanities Notice of Intent to Publish, right? So we're expecting the RFP to come out in July, but they specifically put out a call on their website saying, we know that this is going to be one of those topics that's going to benefit from having complex teams. You're going to have technology experts as well as social scientists in looking at how those work together. So the earlier that teaming can get started, the better. So if you're thinking about some of these areas of ethics that we talked about earlier today, this may be a really interesting call to take a look at. So that basically gives you a bird's eye view of the landscape of what's going on in the federal government. And by no means did we touch on everything available, but hopefully this gives you a sense of the flavor of what's available within data science and AI. So with that, I think we have a few minutes for questions.
Any questions?
So I guess I just also would like to reiterate that, so Laura is planning on sending out a link to where we're posting the slides after this. So I know we embedded a lot of hyperlinks, and if any of these kind of tickled your fancy and you want to read more, the hyperlinks are going to be active in what we send out. So thanks for that. Okay. Thanks.
And very big thank you, Molly. Thank you so much for coming today and finding some time to show us some of these amazing funding opportunities that are already out there and for our faculty to pursue. We very much appreciate you, and I know Pradeep, who could not be with us today, and helped you put that together. Can I quickly ask my group 3 presenters, faculty presenters, to meet me up front, stage left? We're going to take 2 minutes to go over logistics with that group, and then we'll run through our next round of presentations. So everyone gets a, I guess, 60-second break, unless you're a presenter. All right, everyone. We're about to go into our group 3 of faculty lightning round presentations. So I'm going to start with Dr. Megan Manfra, and I'm going to invite her up to the stage to begin.
Great, thanks. And you can just use this. Yep. All right. Thank you, everyone. So I'm putting data science into practice in the history classroom. And how we're doing this is by first identifying the key characteristics of computational thinking and distilling this into a very simple 3-part heuristic of data, patterns, and rules. So take, for example, this data set. Here we have a listing of all of the female members of the House of Representatives, including their political party affiliation and the dates of their service. So if we asked our students to take this data and identify patterns, they might create a graph like this. Push further to identify the patterns in the data, you begin to see a sort of bifurcation here in terms of political party affiliation. It happens right around 1992. Push further to make a generalization or identify a rule about why that's occurring in the data. Students would have to understand the historic context of what happened around the time, for instance, the Clarence Thomas, Anita Hill hearings. This year was later named or dubbed the Year of the Woman because of the increase in the number of women in Congress. They might look more close to home at women like Eva Clayton, who represented North Carolina, and was the first black representative of North Carolina in Congress since 1898 when she was elected to office. So put quite simply, computational thinking and data science not only belongs in STEM classrooms, but absolutely belongs in the humanities and in history classrooms as well. And connected more closely to our topic here of AI, I see AI as part of acting as an intelligent agent to support the design, helping students collect data, analyze data, and visualize it, as well as to enable teachers to better assess student work and student outcomes. And our research has demonstrated that by integrating this into the social studies classroom, we can improve student learning of content knowledge and as well as their computational thinking. Thanks.
So this was part of a engineering research center proposal that a handful of universities had put together, and the theory here is basically using this mathematics, you can assess the risk of any system of systems, big or small, and it's scalable, and you can also assess the agility. Well, that's a big claim. Well, let's look at the math behind that claim. This is where it was published, and what you can see here is basically I guess I don't have, do I have a laser here? Well, the first equation right there is the outcome risk. So the S vector matrix is sensitivity coefficients. They relate these pliable states, the PS states, and the unpliable states. Unpliable states might be something like rainfall or something that's not as easily controlled. Pliable states are things that you can control. And you're looking at the sensitivity between each of those, like rainfall versus number of cars on the road or something like that. And so once you have this, then you can come up with an outcome risk. The outcome risk is that if you have a system where you can have a large change in rate, then your risk is up. The risk being defined as everything stays the same. You're not having any upset conditions. Everything's predictable. Everything is just the way it is now. And the higher that everything changes, the more risk you have. Now, these system coefficients, they're all be time dependent, right? Especially if they're diurnal or something like that. And then it comes down to agility. Agility is the thing that we really wanted to optimize. The agility is the reciprocal of the change in rate in risk. So that's the metric for agility, and above it is the metric for risk, where if the risk has a large change in rate, then that means that you don't have good agility. If the change in rate of the risk is low, then that means you're agile. Things are gonna, if you have an upset condition, it's not gonna change a whole lot. You can recover, you can have auto recovery. And so I gave an example right here, very simple, about some relative things. The original theory that we were going with was that you had 5 systems. You had energy, healthcare, economy, manufacturing, and logistics. Oh, I forgot what the fifth one was. Anyway, the paper I published, that you have up there, looked at just the nuclear energy in the Texas system. But the point is that all of those coefficients have to initially be estimated from an expert. And and that's just an expert estimate. But what you're really interested in is what's reality, especially the time dependence. And that's where machine learning comes in, fitting that to big data sets.
Okay, great. So in all theories of coloration is just involve a colorant, right? So let's say you want to dye something blue, you're going to use a blue dye. That theory's been around for, evolved over the last 200 years or so. But what we find is if you put something like that's colorless, like water, on a fabric, it changes its color also. So the theories don't have any way of handling that. And so the question is, and it's really important in dyeing because you usually dye fabric in a wet state, but when you wear it and when you measure its color, you do so in the dry state. So there's a mismatch here between the manufacturing and the industry and kind of the retail side and what it's used for. And so I wanted to wonder if we could design a neural net that would learn that mapping between the color in the wet state to the color in the dry state. There are norms. This delta E function behind me, okay, is what's called a Euclidean norm, which had been used a lot to measure the distances, but the space isn't at all Euclidean. So what I did is I went ahead and dyed like over 700 different colors with 1, 2, and 3 dye combinations. And if you map that into color space, you see the one that's over here, that's in the wet state, and the other one is in the dry state. And I trained a neural net to learn the mapping between that. But the error function that I'm using is a non-Euclidean error function. So that's something that's a little different in the literature. If you see in this graph here, the ones on the top, delta E's, anything that's below the orange line is acceptable, things that are above are not. So you can see in the wet state, the differences in color are huge, but the neural net was able to learn that difference and made it so that it was perceptively imperceptible. So thank you very much.
Thank you so much for the opportunity to present some of my work here. And the work of the lab and the NC State Hyperpolarization Lab is focused on democratizing molecular imaging and chemical analysis. And so we develop sort of quantum technologies focused around magnetic resonance to advance chemical analysis and molecular imaging at large. So the typical techniques for chemical analysis in chemistry departments, one of the favorites is nuclear magnetic resonance, and then also as a medical imaging tool, MRIs are of course used a lot to get good tissue structures. The issue being that these techniques are particularly expensive, and we would want to move to a place where we can have small devices that can give us the same type of information with high sensitivity, even though we have now devices that we can deliver, broadly speaking. And the way we approach this problem is that we develop very sensitive magnetic sensors that can detect sort of the chemical structure from any substances that you might be interested in, like in your coffee cup, or if you're having your morning breakfast, if you are interested in the chemical composition of your compounds. But then also for molecular imaging, with these techniques that we develop, we can now actually look at the metabolic conversion of molecules inside of brains, as depicted here, and we developed this technology. And so the question is, how can we now leverage artificial intelligence and machine learning to help us with these tasks? So one important task is that if we have these mobile devices that can give us a lot of information that is hard to interpret, especially for the naive user that now wants to go out and just use their tool as a measurement device, then we can train neural networks on the spectra that are acquired to then tell us about the chemicals that are in there. And very similarly, for the medical imaging applications, we're using this new information from these metabolites that we can now image, and we can use neural nets to improve the quality of the data and the robustness of the data that we analyze. Thank you.
Thank
Thank you. So the purpose of my research is to advance the development of materials for use in different engineering applications. And it turns out that the way to improve material behavior is to use composites. This is a very popular approach for increasing efficiency, using resilient materials, sustainability, and applications like civil, aerospace, and biomechanical applications. The issue, however, is that materials are complex, and composite materials in particular are very complex. And the complexity comes from the fact that there are different components of the material that are interacting with each other through an interface. So think like reinforced concrete or layered composites. There's an interface that determines how this material is going to behave. And the traditional methods that we use for predicting behavior, like computational methods, are particularly challenged in that context because they become very difficult to model on the interfaces. They become very challenging in terms of accuracy, and they become very complex and expensive in terms of running these models for large-scale applications because a lot of these interactions happen at small scale. So we need to develop models that capture these interface material behavior properly in a large-scale context for applications in structures and in different areas. And this is where machine learning could be very helpful because it increases efficiency. It avoids the requirement of modeling everything explicitly. However, machine learning is data-driven. We don't have a lot of data in engineering applications, and therefore we are pretty limited in terms of how we can use data for training these material models to sufficient accuracy. So the idea of my research is to use a physics-informed machine learning. We are all in education, so the idea here is to educate machine learning about the actual physical behavior by embedding these physical equations that we know happen on the interfaces within the machine learning model. So this is something that could have much more prediction ability, and it has shown to be pretty accurate for materials in complex applications like modeling of damage on interfaces. Thank you.
Hello, everyone. So the image you saw here is individual retinal neuron cells. It's actually the cells that allow you to see this image. And so my research is focusing on how to image that cells with a much higher resolution in so-called super resolution fluorescent microscopy. And to do that, I developed my own single molecule fluorescent microscope that is showing on the top. And also, I'm a dye chemist, so actually I develop dyes. It's not too far away from the dyes that can dye your clothes and dye your hair. But then I integrate them so that we are able to use them to dye the cells and see what happened and how to label the proteins, the sugars, whatever that nutrients are being used. So the issue is that because we are looking at one molecule at a time, so you see the pictures on the right bottom that is very noisy, and that is the intrinsic issue of the single molecule imaging. So very recently we developed this neural networks to very rudimentary convolutional neural networks to help us to decode this single molecule properties. So for example, what you see here, the magenta is the mitochondria, those are the powerhouses of individual cells, and you see the cyan channel, the yellow channel, those are the backbones, the bones of the cell. So basically, it's telling us the neural network is also helping us to improve the imaging classification. Well, I'm just mostly a domain user other than an expert in machine learning, so I'm much appreciative if anyone can help us to further decode using more sophisticated machine learning algorithms to decode all this single molecule behaviors. Thank you.
Transition here. So my name is Edgar Oviedo. I am in the Prestige Department of Poultry Science in CALS. So we have a Department of Poultry Science because chickens actually are a big part of the agricultural economic in the state of North Carolina. We rank second as a meat producer in the United States. And chicken production actually is organized in big enterprises. We have 9 companies in the state that use technology, electronics, and a lot of sensors in each one of the facilities, and all these are integrated through the internet. So we have a lot of data that is being produced, and it helps then to keep developing better methods, more healthy products, and also to comply with different regulations for food processing. Also, these also keep us good with the traceability of the food products. Even we can obtain data from images, from sensors of temperature, humidity, and big volumes. Even in a chicken house, you can have about 15 sensors, and each house could be producing 1 million values per year, and we have about 5,000 of these houses in the state of North Carolina. So due to this organization in the industry, we have developed programs to train people using these data that are getting from sensors, and this includes artificial intelligence, going from descriptive statistics all the way through machine learning. And one of the limitations is that all these, to adapt this technology, we need to make sure that it's explainable, because the adoption of the technology requires that people are able to use these decision trees and random forests. And so we are seeking collaboration to keep developing this type of products for the industry.
Okay. Hello, my name is Aram Amassian. I'm representing the Carbon Electronics Cluster. We work on emerging semiconductors. So these are semiconductors that don't just use charges, electrons, and holes like in silicon, but they start to use spin, ions, polarons, phonons, excitons, new quantum states in order to enable the next generation semiconductors that will augment silicon, wafer-based technologies, and allow new standalone semiconductor technologies. I invite you to scan this code right here, and you can take a virtual or 3D tour of our lab facilities where we have our shared facilities. So we're a community of 100 researchers here at NC State across 4 colleges and 7 departments. And we find that recently some of our extramural center funding, DOD MURIs, EFRCs, increasingly require use of data science and artificial intelligence. So I'm here also to seek collaborations and support from the university in sort of investing in this direction, I think, which would be very, very important. What we have been doing internally at NC, in our laboratories, is thinking about how do we generate big data sets much more efficiently in the laboratory. And we've been thinking about this in the context of robotics that is connected with artificial intelligence and decision-making algorithms in order to create inputs and outputs that are digitized and allow us to get to the big data a lot more efficiently. And we've been able to show that we can achieve our data intensity, get 10 times more data for the same resource input, time input, energy input. So this allows us to solve material design problems considerably more efficiently. And we're using this to design some of these emerging semiconductor materials that are hopefully going to help us transform North Carolina semiconductor industry in the future. Thank you very much.
Okay, similar to last time, we have a few minutes. So we'll have about 10 minutes to network with our group 3 presenters. So all of our presenters should be here stage right. So if you've heard something you'd like to hear more about or connect with, please join them kind of near the break surface area. And directly following that, we're going to go right into our facilitated discussion. So don't leave just yet. There is also a social at the other end. We'll just have, I think, about 8 to 10 minutes of networking with our group of presenters we just stopped with, or just ended with, and then we'll move on to our facilitated discussion. All right, everyone. I know it hasn't been a lot of time, but this next portion is also going to allow you a lot of networking and FaceTime and collaborative discussion. So before you actually sit in your seats, although Robert, I saw you just sat down, sorry. Before you sit in your seats, we asked you to self-identify into 4 categories today. And I want to actually ask the whole group to come up front here, and we're going to say stage left. Everybody, out of your seats, over here, front left. If you don't already have yourself identified, I'm going to provide you the 4 right here, and we'll get you into the group you think you're most appropriate for. Many of you have identified yourself in 2. I want you to start with what you think is your primary category, and then we might adjust these groupings. So, coming on down, I want the group that has identified themselves as data science and AI research, which is my research is currently focused on the field of data science and AI, and may include the development of methods, algorithms, modeling, and etc. Red, sorry, red color. Red, red group, all the way. I want you on the farthest, I want you as the furthest group. So as far as you can to the wall. Uh-huh. Uh-oh. The second group is green, applied data science and AI. I'm currently applying or interested in applying data science and AI to my research area. That could be a second group, just start grouping yourselves in the next part. Everybody come on down. Sorry, last part of the day, we're getting you moving, but don't worry, we're gonna sit you right back down. The third grouping is impacts of AI. This is yellow. My research interests are focused on the impacts of AI on society, research, education, etc. Let's go ahead. Genevieve is helping. Yes. Yellow. Right in front of the podium. Yellow. Okay. Our very last grouping, let's go ahead and have you at the bottom of the stairs, stage right, is leadership, administration, staff. I'm supporting research and scholarship efforts at NC State. All right. Okay. Dr. Genevieve Garland is here today to help me facilitate this discussion. And what we want to do is try to have fairly similar sized groupings. So is the group I'm missing, this is impacts. Where's my split between applied? You were the only one. Okay. Let's have green in front of this column here. Okay. If you're undecided and one group is smaller, please push to that group. Impacts. Is anybody a yellow maybe as their secondary selection? Does anybody have impacts as their secondary? If so, I might move you to impacts. Okay. I'm getting close. All right, this looks good. How about this group back here? Where are you all going? All right. I'm going to switch my mic walker because I'm going to walk around. Oh, one more thing. Sorry. For those online, sorry. This is going to be the end of our live streaming broadcast, but we're going to have some great discussions here, and we hope to share some of the ideas generated online following today's program. So for those joining us online, thank you, and more resources will be available following. Okay. Now I'm switching more. Okay. Whoa, that one's really loud. Okay. What I'm going to do, I think we're